Oh yeah, 1 minute early for a change. So yeah, just a little bit of pre-show banter before we get started here. Just saying hi to my friends. We have A joining us, Al, who's both A and Al are regular contributors to the WiseAss Slack channel. So thank you very much to both you people. And we have Ibrahim. And so as some of you will notice, I made a new thumbnail for my live stream, and in basically one portion of it, I wrote that I had a PhD in dishwashing, which is basically something my long-term viewers will know about me, but something that maybe some of you newer people won't know about me is that I basically have like no academic credentials. I have one post-secondary course in introductory Java under my belt, and basically from that, which happened in 2013 until now, I haven't really set foot on a university campus, and I've spent all of that time working in kitchens alongside learning programming and software architecture and how to code and stuff like that. So the only real credential I have is that I have at this point over 5 years collectively working in kitchens. So not only do I know how to wash dishes, and can I explain it to someone, but I know how to clean, how to disassemble, deep clean, and reassemble dishwashing machines that are literally the size of an entire room, basically. So it is something at this point in my career I consider to be something I have a level of expertise in. Maybe I'll get there one day with programming. Anyways, the whole point of that is honestly just to make it clear to people that like I'm never trying to pretend to be something I'm not, and I don't actually have any professional credentials. So that makes it even more pathetic if my content is better than people who do have professional credentials. But anyways, that's basically it. Enough rambling. Let's get started. We're on episode 51 of the live stream Q&A. So just to get started here, I just wanted to briefly talk about how to support the show. So if you enjoy what I do here, then do me a favor and consider following me on your preferred social media platforms. So we have a Google Plus page, Facebook page, Twitter, and also consider oh yeah, real good diction going on today. Consider joining our Slack channel, link in the description box down below. Considering YouTube, if you enjoy this content, you can do me a huge favor and hit the like button below. You don't have to right away. I haven't really taught anything, but yeah, that would really help me out. And of course, consider subscribing if you'd like to know exactly when I am live. So that brings me to the money part of this thing. So this channel is partly supported by donations from wonderful people such as yourself. Now, if you can't afford to donate, that is totally fine. Believe me, I know what that's like. I've been there. But if my content helped you, then consider donating what you might have paid for similar content on Udemy or some other platform. Or just donate whatever you'd like. Anything is very graciously accepted. So that's basically it for the commercial for today. And we'll get started with a couple of announcements. So number one, if you've been watching me on social media, then you will know that we have a new live stream schedule. So of course, and this will be the regular schedule. I will keep it to this same schedule for as long as I can. So Sundays at 10 a.m. UTC-7, which is right now, will be the live stream Q&A. So the focus of this particular stream is mainly going to be centered on answering questions for beginners and intermediates, and if I'm able to, more senior developers. But yeah, so the focus here is going to be answering questions. I will also often start with some kind of lesson, but that's really only going to happen if there's something I feel is sort of worth teaching, and that So what I'm saying is sometimes I just do Q&A through the whole thing. So that's on Sundays. Now tomorrow on Mondays at the same time, 10 a.m. UTC -7, I'm kicking off, well, kind of restarting actually a series which I had started at the beginning of this year, and then this year just kind of shat itself, pardon my language, in terms of free time. So I had to drop multiple projects that I was working on and to work on other projects. Very, very busy, blah, blah. Anyways, I'm going to restart my live coding series. So that'll start tomorrow at 10 a.m. and how it'll work is I will basically just work on an application, which I am currently working on. I'm probably going to work on Catalyst, which is the sort of the 7th version, the 7th iteration of the first application I ever built. And I'll probably just, I'm basically rebuilding it in Kotlin, so I'll take you along for that fun stuff. Also, during the live coding sessions, I haven't planned it out 100%, but I'm still going to have the chat open, but I'm going to focus on just coding a lot more and not so much answering questions. If you have your questions, you can either ask them in comments on the videos or ask them here or social media, whatever. So yeah, if you enjoy live coding in Kotlin and watching me stare at my computer screen with a look of consternation like this, then you might enjoy the live stream tomorrow. What else do we got here? So as some of you may have noticed, I am finally making videos again, and my goal is going to be to make about 1 to 3 recorded videos a week. We'll see how far I get, because I still don't have a huge amount of spare time, but I'm definitely going to be working on regular videos. The first video I made was on context in Android, and so that's kind of a preview of the style of these videos that I'm going to be following. And the series is going to be called WTF, which means, what's that for? Did you think it meant something else? Maybe it does sometimes. Anyways, so how that is going to work is I basically have sort of 3 or 4 series planned within WTF. So one will be Android WTF. So basically this is just the topic specific video. So it'll be Android, Kotlin, and I'm debating, I might do one that's software architecture and one that's just programming for just more general stuff. Or I might just lump software architecture in together with programming, because ultimately, you know, it only concerns programmers, and that's one less video playlist. So anyways, that's what's going on with that stuff. So definitely check those videos out. My goal with them is to make the videos as short as necessary, but to also keep it entertaining, to use analogies outside of programming so you understand what I'm talking about. And yeah, I think the first video went pretty well. Also got a really good outtake out of it, which I shared on Facebook if you are fond of watching me swear a whole bunch. So yeah, I think that's it for announcements. That is it for announcements. All right. So anyways, let's get started here. So what I wanted to talk about today, as my computer is churning like crazy, what are we at here? Oh, it's only 40% CPU usage. Okay, so what I wanted to talk about today is recently in my Kotlin MVP calculator repository, I created a new branch in the repository which is labeled coroutines. So what I'll do is I'll just pull that up right now. Bracket cove. Sorry, I was scratching my nose, not picking it. Oh, okay. Here we go. So the repository is Kotlin MVP Calculator, which I've been working on for some time. And the purpose of this application is I just wanted to build a really simple application really well. And some people have criticized me for doing that and say things like, well, why would you bother building something simple really in a very complex way? And my general response to that is, if you can't build something simple in a complex way, then your likelihood of building a complex thing in a complex way is pretty low. So it's basically a learning project. Now, in it, I basically explored a whole bunch of different things, but what we're going to focus on today is probably asynchronous communication. I didn't actually plan too much ahead of time, just to really look at the code and compare some differences. So let me pull the code up. So if you click on the link below, you'll probably be taken to the master branch of the repository. And if you would like to switch to the coroutine branch, you can hit this menu down here and go to coroutine. And let me just open up a link here and we'll go back to master. So what I'll do is, I don't plan to talk for too much longer, but we'll do a little while here. I see I don't think I have any questions yet, so that will kind of, no, I got 1 or 2 questions, so we'll see how we do it. Okay, so let's just really quickly look at the most important thing that I wanted to deal with in this particular project. So we're going to open up a presenter. Now, I'll summarize this really quickly. This is basically model view presenter architecture, but it does include a view model. Now, all this view model is in my architecture, it's just a front-end session state container. So basically what happens is when a button is pressed, the presenter will take whatever is displayed in the calculator. It's a calculator application. It'll take the display of the calculator, it'll feed it to the back end. The back end will decide, yes, it's a valid expression, and then it'll hand it to a calculator, which will calculate the result and then return it. And it can also return an error saying, no, it is not a valid expression. So what'll happen then is that the presenter will take whatever result occurs and it will feed it to the view model. It'll basically just say, here. Once it feeds it to the view model will automatically call back to the presenter once it's done storing the data, and then the presenter finally will take that data and then give it to the view to display. So it's a pretty typical kind of event flow type thing. And how I wired it together in the first version of this project was through use of RxJava 2. So basically what RxJava 2 looks like, I'm going to highlight a couple of things. I realize a lot of people watching this are not going to be familiar at all with RxJava or coroutines. So I'll try and speak in generalities so you can kind of look at what's going on, but I would really encourage you to look at the code afterwards and sort of investigate it more. Firstly, we have this thing called an event stream, which is of type composite disposable. So in just really simple terms, this is basically my handle or hook to all of the asynchronous computations going on in the application or this specific presenter. And the reason why I have this thing is, let's say for example, the user switches to a different activity. That wouldn't be the case in this application because there's only one activity. Or we could take the example of when someone rotates the phone and then the activity is destroyed. In that particular case, I do not want to actually call back to the view because the view might not be constructed yet. So what I do in that particular case is I use this event stream, this thing here, which basically collects every sort of, and this is where I'm going to lose some people, but it basically collects every asynchronous operation. It adds it to like a list, as you can see, event stream.add. And when I want to tear everything down, I just say to this event stream clear. So I wanted to show you that in particular, even if you're not an RxJava person, because the important lesson here is that when we're doing asynchronous programming, we need to know when to start and stop things. That's a very important problem, because if, for example, I didn't care about actually stopping the event stream if the view was not rendered or built yet, then the presenter will send data to the view, and then the view will throw an error because it doesn't exist. That's bad user experience. So anyways, just really quickly, so I explained the event stream. So we've got this thing that watches over the whole event loop. You could call it event loop, I don't know, whatever you want to call it, doesn't matter. And then when someone clicks the evaluate button, the equals sign, then I tell the evaluator, which is like a special use case object, I tell it, hey, do your thing, evaluate this expression. We observe, so we're listening to the result of this on the UI thread, as you can see here, but we're operating, I'll show you in the, I'll have to show you that in the other class, but we say the thread that we're actually operating on is a background thread. Anyways, so yeah, and what happens is once the backend calls back, it'll basically return me an object in on next here. So this is a callback. It's just like an on-click listener in a sense. You click a button, it calls back to your view. That's all that's going on here. It's not actually more complicated than that. And to get a little bit technical, this is known as continuation passing style, CPS, which is a fancy word for callbacks. And it's one way to handle asynchronous code. So I'm sure I've lost a bunch of people. Let's talk about coroutines next, and I'll lose even more people. And if anyone's still around after that, we can talk about some simpler things if you have questions about that. So here we'll look now at the coroutine branch, and we'll sort of look just at the presenter. I won't go through the whole thing with you because we don't have time. But I just wanted to show you my progress on basically corouteinizing my event architecture. So first thing you'll notice in this, just before I continue here, I'm getting further with coroutines and I'm really starting to wrap my head around them. However, I'm not going to guarantee that this code is 100% optimal, but let me just take you through what I know so far. So one of the first things I figured out is if you want kind of like a set and forget type operation that happens asynchronously, then you're going to want to use the launch coroutine builder. So this is similar, how I didn't really plan ahead how to explain this, but basically what's going on is we're calling this same method here, eval.execute. So this is the same thing as what I'm calling in the RxJava spaghetti code mess here. Okay, same method. But somehow I'm able to call it in a direct style manner. So this is like one of the things, as soon as I figured this out about coroutines, this like blew my mind. Coroutines allow you to write asynchronous code in direct style, as opposed to, continuation passing style. So let's just talk briefly about direct style and CPS. So CPS, let me just copy something in here. Oh, that's not where I want to be. That's not where I want to be. Here we go. Okay. Let's copy this. Hopefully the formatting will be intelligible. Doesn't look like it is super intelligible, that's okay. Okay, all I want to talk about here, just really quickly, CPS, this giant annoying word, continuation passing style, just means callbacks. Just means a callback, like you see here. This right here, do this, so do this operation oh, where am I? Return the result here. So this is like a very common way to handle asynchronous programming. Do something, when you're done, give me a result. It works. The problem with it is that you can get like this staircase. I believe it's called callback hell. Not to mention it's pretty damn ugly. So this is CPS. Callbacks. Now direct style. By the way, if the audio jumps super loud or anything like that, please let me know. I'm trying to figure out how to adjust this microphone so that it doesn't go from like quiet to screaming periodically. But yeah, anyways, let's go back to the coroutine code. All right. And here we have direct style. This is what you're used to. Am I in the right view here? Yep. So at first glance, let me pull up the code in Android Studio now. Okay, so at first glance, this does not look like asynchronous code. It is. And how it works is this point right here becomes a suspension point. Now it kind of knows that this is a suspension point because I did add a method to my evaluator. So let's go to evaluate expression, which is the use case. And notice how I've slapped a suspend keyword on here. So this makes it a suspending function. I can't explain to you at the moment in detail what that means because it's just too complicated and difficult. It's not that it is, it's just so different that I needed to basically read about coroutines and suspending functions over several weeks to kind of understand what's going on here. But the beauty of this is I can write asynchronous code, so this will still happen in the background, but I can write it in direct style. I don't need callbacks. I just say, do this operation, the result is here, so this result object would be equivalent to this right here, this data that gets passed back, my data payload. And then I just carry on like normal in direct style, in sequential code. So I just check the result. Hey, if the result was a value, then we update the view model with the appropriate value. If the result was an error, so if the expression was invalid, then we call show error and we just tell the view, hey, display a toast. So anyways, I've only sort of touched the surface of how amazing coroutines are, but this is like one of the things that right off the bat has made me want to basically drop other frameworks like a hot potato. I will always love RxJava. It will always have a dear place in my heart for being one of the most difficult libraries I've ever worked with. And coroutines has so far been difficult as well. A lot of the same concepts. But just for a moment, please compare writing this and being able to cancel. So this thing is just this job tracker here, I believe, if I've configured it properly, is just like our event stream. So when I want to stop everything, I call event stream.clear. With coroutines, what I've done instead is we have our job tracker job. I won't explain what that is. Yeah, I can't really explain what that is, but not easily. But I just understand what it does. When I call this job tracker.cancel, this is like a parent coroutine. It's like a container, a context for all the other coroutines. And what I do, and notice how I pass it in here. I pass it into launch. This sort of associates this coroutine that I've built in here with the job tracker. And then when I want to cancel things, I just call job tracker.cancel. So there's lots more stuff I'm going to be exploring, in particular there's a way of managing asynchronous code. There's many ways, and one of the ones that I'm most interested in as of late is using actors to manage asynchronous code or communication across coroutines and threads. Now, I don't quite understand that well enough to actually talk about it, so I won't. But if you are still wondering if you should transition over to Kotlin from Java, my suggestion is please do. Like, you'll run into things which at first seem very convoluted, and you need to kind of just get away from your sort of Java mindset and be able to recognize, okay, this is different, but it's actually a lot better. So that appears to be the overarching goal of the Kotlin project. So anyways, I'm going to run a quick commercial break. That was my brief lesson on asynchronous code with RxJava versus asynchronous code with Kotlin coroutines. And yeah, quick commercial break, and we'll get to some Q&A. Okay. So I'm told that my microphone is a little too loud. Could someone else confirm that? If two people say it's too loud, I will turn it down. Thank you for letting me know on that. I'm trying to figure this out. So just really quickly off topic, Ibrahim asks, can I joke around and make you laugh? And my response to that is, I had fun once. I hated it. Yeah, absolutely. You can make as many jokes as you want and say whatever the hell you want. And yeah, if you make me laugh, great. Okay, yeah, it sounds like the audio is actually pretty good. For some people, it's even quiet. Thank you. Okay, so let's get to some questions here. Okay, I'm going to try and parse this. How should we do prefetching for the data to be shown in a Recyclerview? So without swipe to refresh action, the data in the Recyclerview gets updated. So Gaurav, maybe, hopefully I'm pronouncing your name properly. So the question here is, how should we do prefetching for the data to be shown in a Recyclerview? For example, without swipe to refresh action, the data in the Recyclerview gets updated. So I believe what you're asking is how should we supply a Recyclerview with fresh data automatically? If you could kind of confirm or rephrase that. I think that's what you mean, but I'm not 100% on that before I try and answer that question, because it wouldn't be I could give you an answer if that is the question, but it'll be pretty generalized because there's different ways to do it, and I can explain to you how I would kind of approach it through like event-driven programming. but I just want to make sure that's actually what you're asking. Okay. Okay, I can riff on this for a little while. Let's look at some code. That'll be fun. Okay. So this question is from Vikas. And Vikas asks, could you please in detail explain the working of Android architecture sample, GitHub browser sample, and all the components used in it? So you're asking something, you're asking a lot. What I would ask you is, so I'll totally pull it up and we'll go over it, but what do you want to know more specifically? Because I don't know what to focus on, and you know, there's a lot. When you say components, do you mean architecture components, as in the library, or do you mean just all of the parts of it? So in any case, while I'm waiting on that, let me pull that up, and we'll have a look. Okay, so this is GitHub browser sample. So I believe this is a more complicated application. Okay, so this is the repository, if I'm not mistaken. Sorry, I have to stretch. So I have actually looked at this repository before, and I've learned a lot from it. Once again, this is from Android Architecture Components. These are all open source, good quality applications, and I encourage anyone watching this to go check out this repository. Lots of great code here. So there's a little note here. It is a relatively more complex and complete example. So if you're not familiar with architecture components, you should check those out first. So I'm just going to hop back into the chat. So do you have a more specific thing you wanted me to focus on? No answer yet. Well, let's just kind of jump in here. So basically what this application is, if I were to sort of summarize it, so when you're building pretty much almost any kind of Android application, you're probably going to want certain types of libraries. So for example, this library is going to be using retrofit for REST. So this is the most common way to communicate data across the network in Android. Dagger2 for dependency injection. What is dependency injection? Just forget that word. It's the word describes it, but it's like a big, scary, bizarre thing. Essentially, dependency injection is when you take the code necessary to build things and you put that code in a different place. So code that is responsible for building objects is not contained within the code, the objects that use those things. That probably doesn't make sense, but really the fundamental key you need to understand with dependency injection is we're taking the code you use to build stuff, like to build retrofit, to build, what else have we got here? To build the architecture components, and you're putting that in a different thing. That different thing is the Dagger2 framework. So Dagger2 is a framework to help you, or in some cases just absolutely confuse the hell out of you, because it's actually pretty complicated. But its intention is to help you to help you effectively build the different parts of your application. So there's a lot I could get into there, but we'll leave it at that. Just double check again. vcast, give me some more info here. More about Dagger 2 and live data. Okay, great. I'll focus on those. So we'll focus on the libraries, and I won't talk so much about the architecture. I'm assuming that's what you're preferring me to do, because like I say, I could talk about this repository for about 6 days. But let's get started here. I'll talk about what the different libraries do, I guess, off the top of my head. So we'll see how it goes. So this, now I gotta remember, this is a model view model application, I believe. Is it or is it not? Okay. Where should I start? Let's go with user. We'll stick to one particular part of the app, and this is model view model, as I see here, because I do not see a presenter or controller. So what I'll do so that I don't talk forever is I'll just take you from one end of the application to the other, and then we'll also hop into the Dagger stuff really, really quickly, and hopefully that'll give you an idea of what these different libraries do. So to begin with, we have a fragment, of course. So most people are aware that a fragment is a really good view. The fragment library is designed to be a view. You can use it for other things, but it's designed to be a view. And then we have, so a couple different things going on. First off, we have the Viewmodel factory. So this is basically like in a sense, some form, this is injected through Dagger. I'll talk about the Dagger stuff at the end because I don't want to just bounce all over the place here. So our Viewmodel factory is how we create view models, of course. App executors is going to be for threading. I won't even ramble about data binding. Data binding is basically how they're going to bind to the data to the view. Wow, what an in-depth explanation that was, Ryan. We won't worry about that stuff. Let's talk about view model and live data. So what we have here is we have a view which is talking to a view model, and this view model is going to be talking to the back end. I feel like I'm doing yoga or something. So how this basically works, the important thing you need to know, let me find the view model here. So let's talk about Viewmodel, which is a class from Android Architecture Components. Sorry, I was in full screen mode here. Let's talk about this Viewmodel here. So what this thing essentially does is it's like a front-end data source that's wired into the back end. Now in Model View Presenter, what would normally happen is the presenter would ask the backend for data or to do some computation. The backend would return that result, and then the presenter would directly call the view. It would say view.do something. View models are different. View models, at least in this context, it's an obscure word which I don't like, but let's just roll with it. View models don't call back to views. In fact, they don't know anything about views at all. What they do is they expose data. So yeah, that's basically it. If you want me to clarify that point, ask later on, because I got to keep rolling here, otherwise I'll talk for like 40 minutes. So we've got the view draws the user interface. We've got the view model exposes data to any view that happens to be listening. So you can have a many-to-one ratio of views to view models. That's kind of cool. So yeah, and the other important point, here's the important point about Android architecture components in general. They're lifecycle aware. So when the user tilts the phone, this view model is automatically going to stop itself. It's going to know, okay, I better not call back to the view, because I know that until that view is recreated, if I send data through the pipeline, then there's going to be a crash potentially. I think it doesn't even really need to work that out, because all it really does is just expose data, so the view will reconnect when it wants to. So yeah, but that's the important thing with Android architecture components, is that most of these things you don't have to explicitly control their life cycle, which is really important. Let's move on. So we'll go next to what the view model talks to. So the view model talks to a database, presumably. Yes, a repository, rather. And so what it's going to do, it's going to get these live data objects, which are like a container. So let me, just give me 2 minutes to draw a diagram to hopefully help you understand how this kind of works. In the meantime, I'm just going to run a commercial break while I draw this thing. Okay, so this is a very crudely, hastily drawn diagram here. So this is what you need to understand about live data. Okay, so whereas we're used to thinking of passing messages between the back end and the front end and just across the app in general as just passing an object from, say, the back end to the back end. How I want you to think of live data, and also this is sort of applies to RxJava as well, is that live data itself in a way is like a tube or a communication channel. So when I say to the repository, return me a live data object, let's see here. When we're returning or creating this live data object from the repository, which is essentially what's going on here, then what we're doing is we're saying to the repository, give me a connection. So what'll happen is each time some part of the app updates the back end, if this live data is hooked up to the front end, the view model, then this live data object will automatically pass the fresh data through the channel. So what I want you to think of is that live data is the communication channel, just a tube even you can think of. And then the resource, or specifically here, yeah, this list of repositories object, is the actual data that goes through it. So that's like the most important thing you need to know about live data, is that in a sense, when I ask something for a live data object, the live data object is not the data I want, it is the connection channel. So, and the way that architecture components is configured is that it basically updates automatically. So let's say I have a fragment, so let's say I have 2 fragments. Here, I'll keep drawing because I have the whiteboard out. So I want you to imagine that these two fragments are on the same UI. Let's just say that's a horribly drawn phone screen down there. God, that looks terrible. So one of the fragments, if I touch it, it changes the room database. It updates the database. And this one shows the freshest data. How architecture components works is when, so this fragment will ask indirectly, we'll skip the Viewmodel thing. This fragment will ask the room database for a live data object, which is the tube. And then once someone hits the update button, then the data will be sent down to the tube automatically. So this, when I hit this button, we might say update username. So that message, update username, gets sent to the backend. The backend will update itself, and then automatically it will pass the fresh data into the live data, the updated data into our live data channel, and then poof, it gets sent into the fragment to display. So I won't talk about that anymore, but hopefully that kind of explains live data. I'll really briefly talk about Dagger 2 a little bit, and then we'll move on. I am trying to be concise. I apologize here. Okay, what are we looking at? Not that. Okay. So I basically, the last, just to reaffirm the point I just made, if I go to the data, is it data? What do they call it here? DB. If I go to the actual database, so I'm looking for an interface thing, aren't I? Abstract class. No, I'm looking for the DAO. Which is the friggin' thing that returns live data? Log. Here we go. Okay, so in particular cases, the repository directly returns these live data objects. In other, when you want to load things and get a payload back, then we have these live data objects. And so hopefully that kind of makes it clear the whole operation of like a model view Viewmodel setup with architecture components. That was a mouthful. Okay, let's look at the Dagger 2 stuff really quickly. I won't spend a lot of time on it because Dagger 2 is not easy to explain, but we'll look at it anyway. So when I go to DI for dependency injection, so this won't really help you because Dagger 2 is complicated, like I say, but a Dagger module is where things get built. So in Java, you would see the new keyword often, or maybe there's a static factory, whatever. In Kotlin, you would just see, of course, the initializer brackets, whatever they're called. A Dagger component provides a way of finding the modules, finding, let's say, finding modules and sub-modules. This is the problem with Dagger 2, is that it's so jargon-laden that I can't even explain the basics of it to you without lots of definitions, so this is difficult. But in a nutshell, modules build things. Components used to be how you built a graph of the dependencies. That's going to confuse the hell out of you, probably. Essentially what it does now is it just helps you locate your modules, which let's look at some code, and that will make things more confusing but slightly easier for me to talk about. Let's just look at Viewmodel modules. So going by what I just said, this will be the place that view models are created. What is this? That's not what I'm looking at. All right, and it should probably, yeah, it's going to have the factory. So just really briefly, what we're doing here in this module is we slap some annotations on a function. This is kind of bugging me out. This is that it's an abstract function. Is this implemented elsewhere? Maybe this is just like a new feature that I'm... To be honest, so I think you need to use binds when it's an interface or an abstract class. And then you would use... What's the other one? I haven't looked at Dagger 2 in 1,000 friggin' years. Well, whatever. I'll explain what this does. This is where you would build a view model that you need. Now, what'll typically happen, this changes depending on which developer, but typically app module will be like the place that you build really high level stuff. So we've got like a retrofit instance or a room instance or just things that are typically used application wide. And then you'll have submodules to build more specific things. So for example, a module to build fragments, a module to build view models, for example. And then these component classes, what I want you to notice is if we go to the application class, here, GitHub app, it should have the component. Does it? No, it has our Android injector, so it'll have, let's see here. This is the thing about this project is the Dagger 2 configuration is quite complex. Okay, here's my component. This is what I was looking for. So it's going to get a hold of this app component object, and like I said before, do I have... Oh, for fuck's sake. Sorry, pardon my language. I wasn't joking about having a PhD in dishwashing, because I'm very used to speaking in kitchen vernacular, which includes lots of swearing. Well, whatever, just take it on faith that this app component thing here is how you actually get a hold of the different modules. You know what, I'm going to stop there because Dagger 2 is so friggin' complex and vague in a sense that I can't really explain it to you in terms that will actually help you. But hopefully that kind of gave you an idea of what's going on. The last thing I'll say is that if you would like a much simpler version of what's going on here that doesn't actually have anything to do Dagger, check out my repository, the MVP calculator repository. And I want you to notice that there is a dependency injection package as well. And there's a class called injector. And all this injector does is it basically builds the presenter. It builds something. So this is like a microscopic version of what Dagger 2 does for you. It creates the things in modules. There are screaming kids outside. Damn kids. It's not the kids' fault. It's the parents' fault. So there's a method to provide the presenter, which looks a lot like... I won't even look at this code anymore, should I? What have we got here? Show me a module. Give me a module. So what I'm just trying to say is that this right here is equivalent to like this provide presenter code. So check this out if you want a more easy conceptual implementation of dependency injection. Holy crap, I'm going to run a quick commercial break. That was a long answer, and I covered a lot of ground there, but hopefully that was useful to some people. Okay. All right, so I'll get to Vikas' question again, or sorry, not Vikas, Gaurav's question in a moment. I just wanted to address a couple comments, just really quick questions that I can answer, and then probably Gaurav's question will be the last question that I answer. Okay. All right, so first off, Marco asks, I know Kotlin coroutines and RxJava cannot compare. I don't know, I'm not certain on that, because I don't necessarily agree with that. Like, I understand what you mean by that, because suspending functions is a very different concept than just doing something on a different thread, and it's a much better concept when you really go into what a suspending function is, it takes a while. But they can do the same thing more efficiently, which is pretty powerful. So is RxJava, I'll try and answer this part though, is RxJava needed now when Kotlin is here with its own map and flat map functions? To be honest, the answer, I'll give you like a 75% complete answer. The other 25% is that coroutines are a big subject and there's a lot of different parts to it. But so far, I have not yet seen a place where I'm just trying to think. On the whole, I have not yet seen a place where RxJava does something significantly easier than coroutines. Now, there are problems that are still arising in my code. One of the ones is using actors with named channels as opposed to shared mutable state. But I can't get into that stuff with you because that requires deep explanation. But what I would say at this point in just simple English here, you can probably drop RxJava like a hot potato if you're good at coroutines. And that comes from an RxJava fanboy. I love RxJava. It's a love-hate relationship, as anyone who's worked with RxJava would know. So hopefully that kind of answers your question there. Can get rid of that. Dashboard. Now, one really quick note on that. Coroutines with the experimental library, I forget exactly what it's called, but there's a library with coroutines, not the core one, which has integration for RxJava. So if you still really like RxJava or kind of want to use it as like a bedrock for your understanding, you can still use Rx and other asynchronous libraries with coroutines. What else? Grav asked, have I worked with spannables in Android? Nope. I see L4Z asked about explaining a module in Dagger 2, and I didn't actually see that. Although I did kind of explain what a module is in Dagger 2. Again, the thing about it is that I can explain to you that a module is where you build things in your dependency injection implementation, but that's probably not really going to help you. Dagger 2 is something that you, if it seems very confusing to you, just understand that that has been the experience of most people who have tried it. But just to answer your question really simply, a module is where you build something. It's where you build one of the pieces that your DI implementation will then grab that piece and plug it in. So that's not a great answer, but hopefully it kind of helps. This is again a kind of a quick question. Hello again, Aswin. So the question was, if we switch, so well, I'll write it out. So a question by Aswin, the MVP pattern is well supported and stable in Java with libraries like Dagger 2, Butterknife, Mockito, RxJava. If we switch to Kotlin, do we miss out on these stable, time-tested libraries? Absolutely not. What I would suggest to you, Aswin, is please do check out my Kotlin MVP calculator tutorial. If you're used to looking at RxJava, then use the master branch. Sorry, I'm not in code mode. Check out this repository, link down below. If you prefer RxJava, look at the master branch, and that will show you how to implement Model View Presenter on Android with RxJava in Kotlin. As far as if you later on, when you want to get into coroutines, you can check out the coroutine branch. This application is too small to really necessitate Dagger 2, but you can use Dagger 2 with Kotlin. My friend Davor, I recall he did run into some quite specific issue, I think, regarding using Kotlin with Dagger 2, and there is the potential for some issues. But the thing about it is Dagger 2 is quite actively developed. Kotlin is very actively developed, so I wouldn't worry too much about that kind of stuff. They're doing a really good job of addressing concerns. So there was a follow-up by Aswin about Kotlin and Realm support. On that, I really have no idea. I've never looked into using Realm with Kotlin, so I don't know what the situation is there. Okay. So the last question, here we go, Gaurav. Okay, so what I'll try and do, Gaurav, is first let me just, I'll paraphrase your question a little bit here. Is that how I spell your name? G-A-U. Okay, so I'm going to paraphrase the question a bit, but Gaurav asks, how do you automatically supply a Recyclerview, holy crap, I can't spell, Recyclerview with fresh data without requiring the user to refresh or act or touch a button? How do you automatically supply a recycler view with fresh data without requiring the user to refresh or touch a button? So, the short general answer to this question is what you need to do is you need to basically make your view or your recycler view essentially just listen to some form of basically an event loop. So how you would do that is through a library like RxJava or coroutines or live data. Live data will work really well. And what you're going to want to do is you need to wire your architecture so that the essentially what I'm saying is the recycler view needs to be hooked up, maybe through the observer pattern, not necessarily directly. This stuff is, I'm covering a lot of ground briefly here, but it needs to be hooked up to an asynchronous data source. So what our goal is, let's say as you mentioned here, you mentioned like a tweet. So let's say we have a view which has a recycler view, and then some decision maker, whatever, Viewmodel or presenter, whatever, that thing, and then we have, say, a retrofit service talking to Twitter API. So I believe, if I'm correct, what you're asking is, let's say I've just loaded the view. I just got the most recent tweets of the logged in user. What you're asking is, let's say someone tweets to that user and updates, and as a result, the view currently does not have the most up-to-date state or data displayed. So what you'll do is through usage of, you could use live data or RxJava, you're going to need to automatically have a callback anytime the retrofit service is updated. So again, we're going to get into implementation specific details. If you're working with a local database like Room, it will automatically update you. If you're working with, say, retrofit with Twitter's API, I don't know exactly how their API works, but you might have to like just keep pinging. You might have to just keep asking for it. Off the top of my head, I don't know of a way that you can, without some kind of session, have a REST API just automatically call back to you. So I'm guessing you would need to just call back. So hopefully I've conceptually explained what you need to do. So one of the most important, if I could kind of summarize it, in some sense, the view should always be the most recent and accurate reflection of the state of the data on the back end. Yeah, the view also serves as an entry point for handling click events and stuff, but generally speaking, this is kind of the goal of the view, is it just displays the most accurate state. So when I say state, I mean the data, the state of the user's data. Therefore, you should design your app to always be listening for the most recent data updates by way of creating, well, I'll call it an event loop, for example, which really, yeah, it's kind of hard to explain, but hopefully you understand what I mean. The relationship of your view to the presenter to the backend should basically form like an event loop or event stream, you could also call it. And this really is something you're going to have to address eventually as a developer. If you've never really worked in, if you're not super familiar with asynchronous code, I'm going to encourage you to try and get into thinking about your architecture as like a streams and events, as opposed to something else. I'm not quite sure what, because I don't even think of my app differently anymore. Now, obviously, your backend will also need to constantly supply the front end with fresh data. That can be dealt with depending on which particular API you're using. And like I say, I'm not really going to go into API specifics here because off the top of my head, I can't think of how exactly to do that. But maybe one solution would be, I'm sure there's developers in the comments who have solved this problem plenty of times, but one solution might be to set like a delay, so every 10 seconds ping the database or ping the retrofit service to see if there's new data. And that's kind of off the top of my head the best answer I can give you. So great question. Hopefully I at least gave you some useful information on there. If you want some idea of how to set up like an event loop thing, look at my code, because that's generally how I do it. Look at the Android architecture blueprints and architecture components code, because it's also built with this kind of event-based architecture in mind. I apologize that I'm rocking back and forth, but my hips really hurt from standing. So yeah, let's just hop into the chat for some final comments, and that'll be it. All right. A couple more Oh, that was a good voice crack. A couple more rapid fire questions here. Okay. Do I have lessons on Espresso testing? No. I've been saying this for like 2 years now. I will eventually get into Espresso testing, but in my particular style of building views, and one of the main benefits, in my opinion, of model view presenter architecture is that you basically offload most of the logic, and logic is the thing that needs to be tested, to the presenter, and then the view just take the data, plug it in, take the data, plug it in. So is it not a bad idea to test the view taking some string and putting it to a label, a text view? You can if you really want to. Generally, I don't bother because my views are so stupid that they don't need to be tested. However, that is a feature of the way I build applications. In some other cases, you might totally want to verify the user interface using Espresso. On my channel, I have nothing to give you, so I'm sorry about that. I do write lots of tests and lots of unit testing, but yeah. That's funny. One person said the audio is too loud, and now it says another person saying it's kind of low. I'm sorry, guys, but I don't know what kind of middle ground I can find. As long as you can hear me, I guess. Kurva match. Victor Kalinowski asked a question. Last question, MVP or MVVM? Today I do Polish accent. What's up, man? Cześć. Akshamesh. So, last question, MVP or model view Viewmodel? I get this question quite a lot, almost every live stream. There are benefits to both. I personally prefer model view presenter, with the understanding that I actually currently use a view model in my approach to model view presenter. And if you're wondering how I do that, I just treat the view model as another part of the model. It's just a data store. I prefer model view presenter mostly because it is less ambiguous, it's very testable, it's very modular, and it's not difficult to understand. Model view Viewmodel, on the other hand, I really like the concept of exposing data to views as opposed to handing data to the views, because then we can get into a situation where we have that many-to-one ratio of views to view models. That's really cool. I like it. What I don't like about model view Viewmodel specifically, I really dislike the name Viewmodel, the way it's kind of used in that context. And what I mean by that is oftentimes it also makes decisions and logic about the view, and then to me that object should certainly not be called a view model if it makes decisions. My general dislike of view model is that, in a sense, I think it very often helps to have a front-end decision maker moving away from all the jargon. And in model view Viewmodel, from what I've observed, it's in a sense an incomplete architecture unless you add some kind of controller or presenter or something. So I dislike model view Viewmodel on those grounds in particular. Now, like I say, I don't really strictly think of my architecture as either MVP or MVVM or MVC. I think of my architecture as, here are these things I want, and here's what they do, and I'm not going to limit myself to doing it just one particular way. So that's kind of my short/long answer there. And then one more question. We have a, do I love Kotlin so much that I will leave Java forever? While Java will always have a place in my heart as the first language I ever used, and for lack of a better term, mastered object-oriented programming, it will always be my entry point to like the most wonderful things I've learned about software architecture and how to build apps better. With that being said, the more I learn about Kotlin, I am quickly being converted to a Kotlin fanboy because it's a friggin' awesome language. It's so good. It really, to me, feels like what Java should be if you were to take all of the things that are annoying about it and make them better. So that's kind of my short answer there. Will I continue to write Java? Yeah, absolutely. But if I ever run into a situation where I can write either Java or Kotlin, I will probably always write Kotlin. It's easier to write, it's more efficient. That's my answer there. So I think that's going to be just about it. Anything else here? Thank you, Gaurav. Gaurav mentioned my explanation is much better than presenters in conferences, and that is a very huge compliment. So thank you very much, Gaurav. I really appreciate that. All right, that's going to be it, everyone. Thank you so much for watching. Tomorrow, if you are free around the same time, then come and join me for some live coding action. And I will be building an app in Kotlin. I'm not sure how much Kotlin I will write because I need to set up the structure of the application first. But yeah, I'm going to be kicking off that series and we'll see how that goes. I don't actually know how long I'll stream for tomorrow, but it'll probably be 1 to 2 hours. And I probably won't answer questions outside of specifically what I'm doing. And I will try to be not as rambly and try to just focus on doing my work, because that's kind of the goal of tomorrow's live stream, is to just show you this is what I do to build apps. So that's basically it. Thank you so much for watching. Consider liking and subscribing if you haven't already. Consider throwing me a couple bucks on PayPal or Patreon if you can afford it, and if you can't afford it, that's totally fine too. Thanks for watching. Peace out.